Good morning. This is the chapter 10 review. It's just the one section. I just want you to go back through that quiz that you've already done. It's the first part of the work energy theorem. We have to figure out what work is, and we have to figure out what power is, and how that relates to energy. And really, the way it relates to energy is the work you put in adds potential energy to the system that you're talking about. And for instance, if you lift something up, you've added work to it, but it's got potential energy. You could let go, and gravity does the rest, and it'll fall toward the earth, and we can calculate how fast it was. And we'll be doing that tomorrow. But today, we're just going to talk about work. So here's a formula for work. Work equals force times distance. Very simple idea. You apply a certain amount of force, it goes for a certain amount of distance, and that's how much work you've put in. Or if you're pushing at an angle, we have to use the cosine of the angle. That'll tell us how much work is actually being performed perpendicular to the surface. And that's why I have this little diagram here, and we'll talk about that momentarily. And then the last thing we talk about in this section quiz is power. Well, power is your work divided by time. And that's a really simple idea. And we find out how much work was put in, divide by the amount of time, and then we have our answer. So I'm going to talk about this. I'm not going to give this a mass. It doesn't really matter right now because I'm not talking about any friction that's holding it back. I'm just going to put this, maybe a block of ice that's on another sheet of ice, and we're going to push it along the ice so that there's very little friction there. And I'm going to put in just a simple 20 newtons of force, pushing it for a distance of 3 meters. And then if I just apply this force and I don't change the amount of force, it's a constant force being applied for 3 meters, then the work being done on this is 20 times 3, or I've done 60 Newton meters of work. And if we look at that unit, that Newton meters, and we see what's all in it, we can figure out that it's actually the same as the unit for energy, which is joules. Newton meters are joules. We'll be able to figure that out later on, and we're going to be talking about that when we're talking about using speed and kinetic energy and all that sort of thing. But for right now, that's just the simple idea. I'm going to take an easy number so that we can find the cosine of it. Say I'm pushing at a very steep angle. Say I'm pushing down and the angle of elevation is 60 degrees. I'm using 60 because I know the cosine of that. And I'm still putting that 20 Newton force on it, but I'm pushing down on it, and it's going to move. It's going to have some movement, and I still have no friction, so I don't have to worry about that. I'm still going to move it the 3 meters. What I have to do is F times the cosine of the angle, right, times the distance, right? The cosine is this guy right here. So we need to know which component of the force is going that way. And we don't care too much about the component of force going down because we still have no friction. So F work equals F cos theta. I have it right there. So let's just go ahead and write it in. 20 newtons times the cosine of 60 times 3 meters. All right, well, the cosine of 60 is a half, so 20 newtons times a half times 3 meters is just going to give me 30 Newton meters of work. All right, so I've done 30 Newton meters of work, which means, if you're pressing down on something, you're not getting as much work out of it. You're not getting your full bang for your buck. You always want to push perpendicular to the surface. You're going to get a lot more push out of it. And that's really the be all and end all of this section. The other one is just using the original force times distance idea and then divide by that 3 seconds on that last problem. Everything else should be good. Number 4 talks about a crane, and all you have to do is take the average of of the force, right? So if a crane starts at 0 newtons of force and ends up at a total of 856 newtons, well, then we just simply find the average, right? And so we'd say 856 minus 0 is 856. And then we divide by 2. 56 is 28. So 428 would be our newtons. And then multiply that by the amount of distance it travels. So I've given you the answer there. You want to use it, go ahead and use it. If not, hey, I think you can do this. It's only 5 questions. You should be done in no time. Good luck.